Hello everyone, welcome to my channel. In this video we are going to learn about doubly linked list. So in the previous videos we have seen what is a linked list and how can we implement the single linked list. Okay, so in the case of a single linked list there will be only one link to the another node, right? So there will be data part and a link pointing to the next node. But in the case of the doubly linked list, so we are having two links here. Okay, one for previous node and the another node for the next node, that is the successor node. Okay, so here we are having the data part and the previous pointer and the next pointer. So we are having two pointers here. In addition to the header pointer, we are having the two pointers. So in the case of the doubly linked list, the name itself defines that. So we are having two links here. Whereas in the case of the singly linked list, so we are having only one link in the list. Okay, so one link is there to point to the next node in the list. So a doubly linked list means the pointers exist between adjacent nodes in both the directions, right? So for the previous node to traverse to the previous node and to traverse to the next upcoming node, and the list can be traversed either forward or backward. That means here the list can be traversed. That means we can visit the nodes in the list either forward, that is forward, or backward. But in the case of the singly linked list, we can move only forward side. Okay, so backward is not possible in the case of the singly linked list. And usually two pointers are maintained to keep track of the list, that is the head and tail. So here also in this linked list also we are maintaining two pointer variables, that is the header pointer and the tail pointer. Okay, so head means it denotes the starting of the linked list and tail denotes the ending of the linked list. So this is how the doubly linked list is represented. So head denotes the starting of the linked list and tail denotes the end of the linked list. So here for each node we are having two pointers, that is one pointing to the previous node and the other pointing to the next node. Okay, in addition to the data. So let's see what is the structure of the doubly linked list. So each node of the doubly linked list consists of three fields, that is the data field or item field and the pointer of the next node in the doubly linked list and pointer of the previous node in the doubly linked list. Okay, as we have seen earlier that, so here the doubly linked list will be having two links to the nodes, that is one is for pointing to the previous node and another pointing to the next node in the doubly linked list. So how to define a node of a doubly linked list? Okay, so in the case of the single linked list, so we are defining the node using the struct variable. So here also we are defining the linked list with the struct variable. So we are defining the data part in the in the structure with the int data, and since we are having the two pointers, that is pointing to the previous node and the next node, so we are taking here two pointers in the structure variable. Okay, struct node star next, that points to the next in the doubly linked list, and the struct node previous, that points to the previous node in the doubly linked list. So we are having the two pointers, we are defining two pointers here in the structure. Okay, so here the only one extra pointer we are adding in the doubly linked list, that is the previous node. So this is how the doubly linked list node will be there. So when you are defining the node of a doubly linked list after creating the structure variable, then the node will be created here. Okay, so when you are going to give the malloc function, when you are using the malloc function, then certain space will be allocated for the node. Doubly linked list is a collection of nodes linked together in a sequential way, and so we are having the two pointers that point to the forward direction and backward direction. So in the doubly linked list we can move forward from starting from head of the linked list to the ending of the linked list, and then similarly we can traverse backward also from the tail of the linked list to the front of the, that is the head of the linked list. But in a single linked list it is not possible. We can move only forward direction in the single linked list. Doubly linked list is almost similar to singly linked list except it has the two address or reference fields. Okay, so here we are using the two fields, that is the previous node address field and the next node address field. Okay, so this is the only difference between the doubly linked list and single linked list. So we are using the two links that points to the, so one pointing to the previous node and another pointing to the next node. So first and last node of a linked list contains a terminator generator, generally a null value that determines the start and end of the list. So here in the doubly linked list we are having the starting of the linked list will be denoted by a null value here. Okay, since the head part is not pointing to, so the head part will not be having any previous node, and tail part is not having the next node, right? That's why we are terminating it with a null value. Okay, so one link will be terminated with a null value. So doubly linked list is sometimes referred to as a bidirectional linked list since it allows traversal of nodes in both the directions. Okay, it is also called as the bidirectional linked list because you can traverse either forward or backward in the doubly linked list. Since the doubly linked list allows the traversal of nodes in both the directions, so we can keep track of both the first and the last nodes, right? So in the doubly linked list we can traverse either forward or backward direction in any direction. So we can easily access first and last nodes here in the doubly linked list. So this is the diagram. So here the starting header node is represented by a null value, right? So one link is represented by a null value that denotes the start of the list, and the tail of the list. Okay, so the tail of the linked list node is represented by a null value that denotes the tail or ending of the linked list. Since the header node is not having the previous node and the tail node is not having the successor node, so that's why we are using the null value for representing this. So let us see the advantages over the singly linked list and drawbacks also. So in the doubly linked list can be traveled in both the forward and backward direction. So we can move from the head of the linked list to the ending of the linked list, or ending of the linked list to the head of the linked list. Both in the both directions we can travel. And similarly, the delete operation in the doubly linked list is more efficient if pointer to the node to be deleted is given. So what is the advantage of moving forward direction and backward direction in the given linked list means? So we can easily search the particular node in the given linked list. And similarly, we can apply the operations like insertion, deletion, traversing, reversing easily on a doubly linked list rather than a single linked list. So in the case of single linked list, if you are traversing from the starting of the linked list to the ending of the linked list, from the head to the tail, then you can visit every node only once in the single linked list. But it is not possible, but we cannot travel backward, right? So we can visit every node in the list only once in the case of the single linked list. But here in the case of the doubly linked list, you can travel forward and backward direction. That means we can visit a node in the linked list any number of times. Okay, so that's why the delete operation in the doubly linked list is more efficient if pointer to the node to be deleted is given. Okay, so we can implement the operations on the doubly linked list much efficient than the single linked list. Disadvantages over the single linked list. So every node of the double linked list require extra space for a previous pointer. So here the drawback of the double linked list is, so it needs the extra pointer. In the single linked list we are having only one pointer pointing to the next node. But here we are using two pointers that points to the previous node and next node. So it requires extra space. Okay. And another drawback is that all operations require an extra pointer previous to be maintained. Okay. So all the operations require the extra pointer to maintain the previous node. So this is also one of the drawback of the double linked list. So now let us see how can we perform the insertion, deletion operations on the double linked list. Similar to the how we are implementing the insertion and deletion operations on the single linked list, similarly we can implement it on the double linked list also. So first we will see how can we perform the insertion operation at the front of the linked list. Okay, so here I want to insert a node at the front of the linked list. Okay, so pointer equals to header dot r link. Okay, so we are denoting the previous node and the next node using the left link and right link. Okay, so here, so first of all, the pointer, we are denoting a pointer here that points to the header dot r link, that is to the right side of the link, right link. So the given linked list, so we can traverse either backward and forward direction. So I am taking a linked list with the 3 nodes. Okay, so this is the header node. So pointer is equals to header dot r link. So the pointer PTR points to the right link, that is the next node. Okay, so this is the pointer. New equals to get node of node. So here, using this function, we are going to generate a new node here. That is the new node that I want to insert at the front. So this is the new node that is created. If new is not equals to null, then so if the given newly generated node is not equals to null, then new dot l link equals to header. That means we are going to insert this node at the front of the given linked list. Okay, so here the new is not equals to null, right? So that's why I am going to link the left side of the new link to the header. Okay, and then new dot r link equals to pointer. So new dot right link. So this is the right link is equals to pointer. So pointer will point to this one. And pointer dot left link equals to new. Sorry. Here the new dot left link equals to header. That means, so we are going to make the header pointer pointing to the new dot left link. So by this statement, so the header pointer will start pointing to the new node. So here header will pointing to this node. Okay. Next, header dot r link is equals to new. So header dot r link, that is the right link, must be equals to new pointer. Okay, so here the right link of the header will become the new. That means it will start pointing to this pointer. Okay, and new dot r link equals to, so here the new dot r link equals to pointer. So new one dot right side link equals to pointer, and the pointer dot left link equals to new. So since you here are having the doubly linked list, so there will be 2 pointers here. So one is new dot r link, that is new dot r link equals to pointer. So it will first pointing to this one. Okay, and then pointer dot left link equals to new. So here the pointer dot left link equals to new. So here it will be, so we are going to add this, the new node to the given linked list. Okay, and new dot data equals to x. So it will be x. So like that, so this node, new node will be added to this doubly linked list. Okay, after adding this, so here this code means it is going to generate the 2 pointers for the given node, and it is going to move the header pointer to the new node. Okay, so if the new node is not equals to null, then we are going to make it, we are going to print that unable to allocate the memory for inserting a new node. Okay, so next one is the insertion at the end of the node, at the end of the given linked list. So this is the linked list with the 3 nodes. So here this is the starting node, so this is the header node. Okay, so here the first one is given pointer equals to header. That means the header is going to, so we are going to assign a new pointer to the header node, that is the pointer. Okay, and then while pointer dot right link is not equals to null, that means if there is a node, no nodes in the given linked list, then we are going to skip this while loop. But this linked list, the given node is connected to the remaining nodes. Okay, that's why we are going to enter the while loop. Pointer equals to pointer dot right link. So we are going to traverse to the node. Okay, since we have to insert the given new node at the end of the linked list, so the pointer will start traversing to the next one, next node. So pointer equals to pointer dot right link. So it is going to traverse to the right link. Okay, so it will point to the next one. Okay, so how long the pointer will traverse until the right link will equals to null. So it is going to check the given node. So the right link is not equals to null. So again it will point to the next one. So here the pointer is the right link is equals to null. So it will come out of the while loop and it is going to, so now we are going to create a new node here to insert at the ending of the linked list. Then new dot left link equals to pointer. Okay. So new dot left link is equals to pointer. So here new dot left link equals to pointer. So this is a new node. Okay, so this is a new node, right? So new dot left link. So this is the right left side part is equals to pointer. That is this pointer we are going to point here. Okay, and pointer dot right link equals to new. The pointer dot right link is equals to new. Okay, so here two pointers are pointed between the nodes, and new dot data equals to x. So then data part of the new node is equals to x. Okay, now so here the null part will be removed and the end of this node will be null. So like this the new node will be inserted at the end of the linked list. So next one is insertion at any position in the linked list. Okay, so in the last two things we have seen the starting of the linked list, ending of the linked list, and inserting at any position. That means after a particular node we are going to insert the value. So for that, first of all we have to search that particular key in the given linked list, and then we have to add the new node to the doubly linked list. Okay, so here we are taking a new pointer here that points to the header node. Okay, that is the P. While pointer dot data are not equals to key, so pointer data value is not equals to key. That means suppose I am searching for the data x. Okay, so this is the data x I am going to search here. Okay, so pointer dot data, so the data of the first node is not equals to key, and pointer dot right link is not equals to null. So the right link will be null only for the ending of the linked list. Okay, so these two conditions are satisfied. That's why we enter the while loop here. So pointer equals to pointer dot right link. So until this condition satisfies, we are going to traverse to the linked list. Okay. Okay. So what will happen here? The pointer will point to the right side of the linked list. So it will point to the next one. Okay. So now here new equals to get node of node. So we are going to create a new node here. Okay. And if new equals to null, then memory is not available. But here the new value is not equals to null, right? So we are going to the next thing. So if the pointer dot right link is equals to null, so here the pointer right link is equals to null. No, it is not equals to null, right? So what will happen here? So new dot left link equals to pointer. Okay. So here the right side part is not equals to, so here the key that we have searched is not having the null value at the right link. Okay, so that's why, so we are going to make the new dot L link. So this is a new node. So new dot left link is equals to pointer. So we are going to insert this new node here after the particular key value search, key value x here. Okay, and then pointer dot right link equals to new. So pointer dot right link is equals to new. Okay, since we are going to add this node at the middle of the linked list, so we have to link the right side part of the new node also to the linked list. Okay, so next what will happen here? New dot right link equals to null. So new dot right link equals to null. Okay, so we're going to make it as a, sorry, this one is for the pointer dot right link equals to null. So here the pointer right link is not equals to null, right? So we are going to this else code. So pointer 1 equals to pointer dot right link. Okay, so this will be okay. Next, new dot right link equals to pointer 1. So here we are going to take another one, that is a pointer 1, so which will point to the new one. We are considering another key called pointer 1 here. So for that points to the next one. Okay. So here the pointer dot right link is equals to null. So pointer dot right link is not equals to null. So that's why we're going to skip the if part here. And when we enter the else part, so pointer 1 equals to, so we're going to take new pointer called pointer 1, which is the right link of the pointer. So the right link of the pointer. So this is the pointer 1. Okay. And so we're going to, we have created the new node here, right? The new node. So pointer new dot left link equals to pointer. So new dot left link is equals to pointer. So we have to remove this the links between the already existing nodes, and then new dot left link equals to pointer, and new dot right link equals to pointer 1. Okay, new dot right link. So since we are adding the node at the middle of the linked list, we have to connect the left side left link and right link of the new node to the existing nodes. So new dot right link is equals to pointer 1. Okay, it will point to the pointer 1, and pointer dot right link equals to new. So pointer dot right link is equals to new. Okay, and pointer 1 dot left link equals to new. So pointer 1 dot left link is equals to new. That means we are going to add this node to the middle of the linked list. Okay, pointer equals to new. So next the pointer will traverse to the new node. Okay, and we are going to insert some data to the node, that is 7. Okay, so after this, so the new node will be added to the existing linked list. Okay, so here the new node will be added to the existing linked list, so which is having the data 7. Okay, so like this we are going to add it to the linked list. Okay, so insertion at the any position. Now let us see the next one, that is the deletion at the front and deletion at the end of the linked list, and the deletion at any position in the linked list. So now deletion at the front of the linked list. So here the pointer equals to header dot right link. So we are going to create a new pointer called pointer that points to the right part of the header. And if pointer equals to null, then list is empty. So here the pointer value is not null, right? We are having some nodes in the linked list. So we'll skip the if part and we'll go to the else part. So pointer 1 equals to pointer dot r link. Okay, so we are creating another pointer, that is the pointer 1. So which is the pointer dot r link. So which is the right side of the pointer. So this is the p1. Okay, and header dot r link equals to pointer 1. Okay, so header dot right link equals to pointer 1. Okay, so we are going to move the header to the p1, right? So header dot r link equals to pointer 1. This one is reversed actually, so we have to reverse it. Okay, so here the pointer 1 is there. If pointer 1 is not equals to null, so since we have to delete the node at the front of the linked list, so pointer 1 is not equals to null, right? So that's why pointer 1 dot left link equals to header. Okay, so here so it is not equals to linked list, right? So that's why the pointer 1 dot left link will be header. So here for deletion at the front of the linked list, so pointer equals to header dot r link. So header dot right link equals to pointer. Okay, and if pointer equals to null, so pointer is not equals to null. So that's why we are skipping the if part and we are going to the else part. So pointer 1 equals to pointer dot r link. So here we will take another node. Okay, so another node will be there here. Okay, so here the pointer 1 equals to pointer dot r link. So pointer 1. So this is the pointer 1. So if pointer 1 equals to pointer dot right link. Okay, so pointer 1 is a new pointer with the right link of the pointer. So header dot r link equals to pointer 1. Okay, so we are going to remove the header node here. Okay, and then if pointer not equals to null, so we are going to make the pointer 1 dot left link equals to header. Okay, so if the pointer 1 value is not equals to null, we are going to make the pointer 1 dot left link as the header. Okay, so this will become the header, and so we are going to write on the pointer here. So pointer which is pointing to this. So we are going to remove the header node here, and the value at the starting of the linked list will be deleted. So next one is the deletion at the end of the linked list. So we want to delete the node at the end of the linked list. So here we are taking the pointer and header values. Okay, while pointer dot right link is not equals to null. So until the right side value, that is, we have to find the node that the right link which is having the null value. So we have to delete that particular node. Okay, until the right link is not equals to null, we have to traverse through the linked list. So pointer equals to pointer dot r link. So we have to traverse through the linked list. If pointer equals to header, okay, if the pointer value is equals to header, then print the list is empty and no deletion is made. So if you are not able to traverse to the linked list, that means if the list is empty, then pointer cannot traverse to the linked list, right? Okay, so but here we are having the number of nodes in the linked list, so that's why we are going to the else part. Pointer 1 equals to pointer dot left link. Okay, so pointer 1 is equals to pointer dot left link. So pointer 1 is there here. Okay, so here the pointer will point to the linked list, right? So here the pointer will point traverse to the linked list for the while loop. So we will start traversing the p until the right link is not equals to null. Okay, so when the pointer reaches the end of the linked list, then the right link is equals to null. So then we will come out of the while loop, and if pointer equals to header, so here the pointer is not equal to header, so we will skip the if part and we will go to the else part here. So pointer 1 equals to pointer dot left link. So here we will take a new node, that is the pointer 1. Okay, and then pointer 1 dot right link equals to null. Okay, and pointer 1 dot right link, so right link is equals to null. So we are going to make the right link as null since we want to remove this particular node. Okay, and return the node pointer. So we are going to remove this node from the linked list. So next one is deleting any node from the Doubly linked list at any position. Okay, so here we are going to delete a node from the linked list at any position in the Doubly linked list. So by using a key value, so after the particular key value we have to insert the node, delete the node. So here pointer equals to header dot r link. So we are taking a pointer, denoting a pointer that points to the right link of the header. So right link is this node, right? So it will point to this node, pointer. Okay. If pointer is null, then print list is empty. But here the pointer is not null, so we will skip the if part here. Then coming to the while loop, pointer dot data not equals to key and pointer dot right link not equals to null. Okay, so here the pointer dot data is not equals to key value, that is the x value, right? And the pointer dot right link is not equals to null, and pointer right link is not null. That means the null value will be only for the end of the linked list. Here the right link value is not equals to null. Okay, so until this while loop condition satisfies, we have to traverse the pointer to the linked list. Okay, so what we have to do, we have to move the pointer to the right link of the pointer dot r link. So that means we have to move the pointer to the next node. Okay, so we are going to move the pointer to the next node until we find the key value or until the right link is null. Okay, so after moving the pointer to the next one, so next we are going to move this to the next node, pointer p. Okay, so here after that one, what will happen? If pointer dot data equals to key, that means we have found the data value x here. So then make the pointer 1 equals to pointer dot left link. So we are creating a new pointer, that is pointer 1 with the at the pointer left link. So left link is this one. So this is the pointer P1, and pointer dot right link equals to pointer 2. That means we are creating another pointer P2. This is the right link of the pointer. Okay, so here we are having the two pointers, P1 and P2. Okay, and then make pointer 1 dot R link equals to pointer 2. Okay, pointer 1 dot right link. So this is the right link, right? Equals to pointer 2. So we are going to denote, we have to link these two nodes because we want to remove the node with the data value x. And then if pointer 2 equals to null, if the pointer 2 value is null here, right, because it is at the end of the linked list, okay, then we have to link the left link of the pointer 2 to the pointer 1. Okay, so here this condition satisfies, so we are going to connect the left link of pointer 2 to right link of pointer 1. Okay, so now we have satisfied the if condition, and we are going to return the pointer node to the memory manager. That means we are removing the pointer node. Okay, so here we are going to remove the data value with the x, okay, and return it to the manager. So now after deleting, so we are having only 3 nodes in the linked list. So this is about how we implement the operations in the doubly linked list.